Hi, this is a lesson on the unit circle. Now the unit circle, among other things, is a convenient way to keep track of all the exact values and the common radian measure angles that you work with. So it's, although it cannot be taken into an exam, you can't take one of these with you, it does provide in the course of the unit a way to keep track of things, and it helps organize and it helps you to understand the exact value ratios for the special angles. So we begin with this. A unit circle is a circle at the origin, and it has a radius of exactly 1 unit, so that's drawn in like that. The equation of the unit circle would be x squared plus y squared is equal to 1, where we work with the standard equation of a circle, but adjusted to this one. You don't work with that too often in this unit, though. And if we took a closer look, and if we drew the angle theta, the rotation angle, in quadrant 1, this would be true in any of the quadrants, though. We have our x value, we have our y value, and then we have the radius. No big deal. That's pretty standard. But if we go into both the cosine and the sine ratios, first off, the cosine, which is always defined as x over r, if we replace the r with 1, then this ratio will simplify to that, x over 1, which of course could be written as just plain x. So cos theta is equal to x. And that probably doesn't sound like that big of a deal, but let's take a look at the sine, which leads us to a similar place. Sine theta is y over r, but because the radius is 1 unit, simplifies to y over 1, and then finally just to y. So the implications of this are that on a unit circle, the coordinates on the unit circle itself are going to be represented as cos theta sine theta, because cos theta is equivalent to x, sine theta is equal to y. Now this doesn't shock people much, because already most people have made the connection between cos and x and sine and y just because of the basic ratios. But what it leads us to, if we look at the circle and we note that the domain is from -1 to +1, we can now state that cosine theta, the cos ratio, will be always between -1 and +1, which has to be true, by the way. You cannot have a cos ratio outside of that interval. And the range by inspection is from 1 to -1, so y is between -1 and 1, so therefore that would mean sine theta is between 1 and -1. Always true. And as well, if we were to take a look at the quadrantals values, like those are the 0, the 90 degrees, the 180, the 270, we can come up with some other conclusions. So all I've got here are the 4 intercepts along the way. And because we know, for example, that the x value is cos, it would mean for that first x-intercept that the cosine of 0 degrees, or 0 rads, must be equal to 1. Now this is easy to verify on your calculator. It's one of those regular quadrantals, but it's a good way to visualize those quadrantals. So the cos of 0 is equal to 1, and the sine of 0 would have to be equal to 0. Has to be, because on a unit circle, those coordinates will represent cos theta and sine theta. And you could go all the way around the circle in this way. The cos of 90 degrees, or pi over 2, will be 0. And again, easy to verify in your calculator, but we can see it in front of us on the circle. And also, the sine of pi over 2 is equal to 1. Has to be that way, because that's the y coordinate, which is sine. Keep going around, the cosine of 180 degrees, or the cosine of pi, will have to be -1. And the sine of pi will be equal to 0. Go down to 270 degrees, and you'll get the cos of 3 pi over 2 is equal to 0. And the sine of 3 pi over 2 is equal to -1. So a lot of people like the unit circle just to remember what the quadrantal values are, at least for sine and cos. Now the reciprocal ones you'd have to find by taking the reciprocal of these, but it does a nice job for this. It also does a good job for the 30, the 45, and the 60 degree angles. So let's take a look at a few questions, and then we can work our way towards those special angles. So if we have a point, 0.7986, comma, negative 0.6018 on the unit circle, we want to find the value of the rotation angle, in this case to the nearest degree. So if you don't know the characteristics of the unit circle, you will have a hard time with this question. But because we know what those coordinates represent, we can solve it fairly easily. We have to identify where we are, though. And because x is positive and y is negative, we know that we have to be in quadrant 4. That's the only quadrant where x and y satisfy those conditions. Next thing you got to be aware of is that x value, 0.7986, is the cos ratio for whatever angle we're looking for. So the cosine of theta is 0.7986. Moreover, the sine of theta has to be negative 0.6018. That's the y-coordinate. Now this is overkill. We've got two pieces of information that should provide us with the same answer, but really we just need one of them. And I'm going to find the reference angle in degrees based on this information. Now you could use either cos, or you could use sine, or you could do both just to make sure that everything worked out. But if you found the reference angle by going second cos, you will get 37 degrees to the nearest degree. And remember, if you chose to use sine, you would not use the negative. Just key in the absolute value of it. So we now know we have a 37 degree reference angle in quadrant 4. So this is what our diagram would look like. There's the point on the circle, there's the reference angle, so by subtracting that 37 degrees from 360, we'll get an angle of 323 degrees. Now that is actually an unusual use of the unit circle. I did this one simply because, for practice on it. The unit circle is mostly there for you, to give you a way to keep track of things. It's not normally, a source of a question in its own right. Let's do one more, and this is leading us more towards the exact values that we have to get familiar with. So in this case, we have the point negative square root 3 over 2, comma 1/2 is on the unit circle, and we want to find the rotation angle, this time in rads. And I'm not even going to use a calculator for this one, although you could. I first off note that I'm in quadrant 2. Excuse that ordered pair slipping away a little bit on me. Because cosine is negative and sine is positive, we have to be in quadrant 2. Now, cosine theta is equal to root 3 over 2 tells me that the reference angle has to be 30 degrees or pi over 6. That's one of those exact values. Now, if you keyed it into your calculator, you would get that. So we have a pi over 6 angle in quadrant 2. Now, you could have used the sine value as well, but those are special angles. You do need to know them. And if we take that pi over 6 angle in quadrant 2, then it means that our rotation angle would be 5 pi over 6. And again, you have the choice. Had you done this all in degrees and converted to rads afterwards, that's okay. But I would really encourage you to be weaning yourself off that and stick strictly to rads for these familiar values. So there is our angle. Now I'm going to draw a circle with the basic information of the 4 quadrantals, and I've got the ordered pairs, and I've also got the angles given in rads, not degrees. And as you can see, I've got the what appears to be 30, 45, and 60, or if you prefer, pi over 6, pi over 4, pi over 3 angles in rads drawn into each of the 4 quadrants. So to fill in this unit circle completely, I'm going to draw in the coordinates for those angles. And I'll do it quadrant by quadrant. So starting in the first quadrant, those are the angles. Pi over 6, 30 degrees. Pi over 4, 45 degrees. Pi over 3, 60 degrees. And I've got the ordered pairs. Now you need to remember that for that pi over 6, for example, root 3 over 2 means that the cosine of pi over 6 is equal to root 3 over 2. It means that the sine of pi over 6 is 1/2, but they also represent the ordered pair for it. And the same thing for pi over 4. The cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is root 2 over 2, or if you preferred, 1 over square root 2. And then pi over 3, same thing. The cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. So I repeat again that those ordered pairs give us the cosine and the sine value ratios for those angles. And when we move into quadrant 2, those values aren't going to change, but their signs will. So 2 pi over 3, or 120 degrees, would give us the same cosine value as pi over 3. The only difference is that it's negative. So the cosine of 2 pi over 3 is negative 1/2. The sine of 2 pi over 3 is root 3 over 2, but positive in that quadrant. And then for 3 pi over 4, that's 135 degrees. The cosine of 3 pi over 4 is negative root 2 over 2, and the sine of that is root 2 over 2. So anytime you have that pi over 4, a 45-degree reference angle, you will get the same values for those two ratios, but the signs would change. And then for 5 pi over 6, or 150 degrees, the cosine of that is negative root 3 over 2. The sine of that is 1/2. So again, that 30-degree or pi over 6 reference angle will produce the same cosine and sine values. And we'll see that in quadrant 3. 7 pi over 6, 5 pi over 4, and 4 pi over 3 would be those reference angles in that quadrant. Always multiples of 6 for the denominator, 4 for the denominator, 3 for the denominator. And you can see there that all the measurements, all the values are negative for cosine and sine. So the cosine of 7 pi over 6 is negative root 3 over 2. The sine of 7 pi over 6 is negative 1/2. And then 5 pi over 4, negative root 2 over 2, and then negative root 2 over 2. They're the same as always. And 4 pi over 3, that pi over 3 or 60-degree reference angle, negative 1/2 comma negative root 3 over 2. And then finally in quadrant 4, 11 pi over 6, 7 pi over 4, 5 pi over 3. And then the ratios are the same, except that the cosine, or the x, is positive, the sine is negative. So this is the unit circle with virtually everything on it. And what I would recommend is to print off a copy of this and keep it around and work at getting comfortable with it. You really do want to have this thing completely memorized. And there's lots of little patterns along the way, not least of which is that they're the same numbers for pi over 3 and pi over 6. So you just have to know which one goes with what. But there's not an actual lot of numbers that you need to memorize. You just need to know what goes with what. But get familiar with it. I really find in trig, even as things get really complicated, because really the first half of the unit is just building skills, learning these things. The second half is where you start applying them. But people get bogged down in the little details. It's not the bigger questions with trig they struggle with. It's just this little stuff. So this is where you really want to put the time in to get comfortable with those ones, so you feel confident that you can get the exact values, or go the radian measure angle for these main degrees. And if you can handle those with comfort and speed, you'll be fine. So that's it for this lesson. The next lesson will actually be working with some of these values, but this is just the basic information. Thank you for your